Welcome back, folks, to Precalculus. Today we're in Chapter 1, Section 6, talking about other types of equations, okay? And we're going to talk about equations in quadratic form. So any equation in the form of ax to the 2n plus bx to the n plus c equal to 0 is going to be in quadratic form, okay? Notice that the exponent here is double what the exponent is here. Okay, so we can attempt to solve these in these forms by using factoring, the quadratic formula. It works for everything, not just strict quadratic, but anything in quadratic form, and by completing the square. Okay, so an example of an equation in quadratic form might be like x to the 6th plus 5x cubed plus 2. That's one. Or, for example, x to the 2/3 plus x to the 1/3, it doesn't matter, plus 5. Okay, notice in both these scenarios, the leading exponent, the degree, is double what the middle exponent is. Okay, so polynomial equations of degree n. So a polynomial is the equations of any equation of the form a sub n x to the n plus another constant and x to the power below it, and so on and so forth, on down to x to the first power plus maybe a constant, okay, is equal to 0. All right, so all of these a sub n's, a sub n minus 1, etc., those are all elements of the set of all real numbers. They're called coefficients. So these equations should be set equal to 0, okay, so that we can begin solving. All right, a couple more vocab here. A rational equation is an equation containing a rational expression or a fractional expression. Okay, a rational exponent is a fractional exponent. Remember, rational means fraction. Okay, so we're going to dive right into solving some polynomial equations here, and we're just going to start by solving this example on the left. So first things first, we want to make it equal to 0. So 4x cubed minus 6x squared minus 10x equals 0. We always want to check and see if we can pull out a GCF. So in this case, the GCF is 2x. So that leaves us with 2x squared minus 3x minus 5. Okay, now we got a little AC method that we need to do. So 2 times negative 5 is negative 10. I can write that up here. Factors of negative 10 that add up to negative 3 are negative 5 and 2. So 2x squared minus 5x plus 2x minus 5 equals 0. And now it's just time to group. So 2x, we can pull out an x, leaves us with a 2x minus 5. And we can pull out a 1, which leaves us with a 2x minus 5. Now we can pull out a 2x minus 5. And that's going to leave us with an x plus 1. And notice now we are in a completely factored form. What we call this is a product of linear factors. Okay, and now we can apply the 0 product property, and we get x is equal to 0, x is equal to 5 halves, and x is equal to negative 1. So that does hold true. We get 3 answers. All right, we get 3 answers. Our polynomial is degree 3, so the fundamental theorem of algebra holds true. Go ahead and pause your video and make this polynomial equal to 0. Use a little bit of grouping and see if you can find all the zeros for this one. Okay, let's dive back into solving some rational equations now. Now, this one here, the first one, is a little bit more simple. So what I'm going to do is I'm going to skip this one, and I'm going to do the next one. And then in a second here, I'm going to ask you to go back and do this one on your own. Okay, so I'll show you guys how to do this one. So jumping down here, first thing we want to do is we want to figure out what is the least common denominator. Okay, what's the least common denominator? So what do all these denominators have in common? Well, we need to have an x, we know that. Clearly, we need to have an x minus 2. And this one right here, x squared minus 4, is really just x plus 2, x minus 2. It's difference of squares, binomial conjugates. So it already has an x minus 2 in it, but it also has an x plus 2. Okay? So because all three of these are missing some piece, this is our least common denominator, x times x minus 2 times x plus 2. That way, if we have all the common denominators, we can smash all these together, we can add and subtract fractions, combine them, set it equal to 0, and solve from there. Okay, so what we're going to do is we're going to multiply everything by x times x minus 2 times x plus 2. Okay, the left and the right side. So what's going to happen here, first of all, by multiplying the right side by all this, it's going to be 0 still. So that's good. We can still have it equal to 0. Now let's look and see what happens to this equation right here. Just this little first 1 over x minus 2. If I multiply it by this whole thing, the x minus 2 over the x minus 2 are going to cancel out. So I'm going to be left with x times x plus 2. Now, let's go through and let's look at the middle one, 1 over x. Well, if I multiply everything here on top there, okay, the x's will cancel out, leaving us with just x minus 2 times x plus 2. And lastly, if we just look at this last equation, or this last little fraction here, okay, if we put this whole thing on top, the x plus 2, x minus 2 are going to cancel out with the x plus 2, x minus 2 on the bottom, and leave us with just an x. So you see it looks like it's a lot more friendly looking to solve. So now it's just a matter of simplifying. This is x squared plus 2x plus x squared minus 4 minus x is equal to 0. Let's combine some like terms. So we got 2x squareds plus an x minus a 4 equals 0. Very friendly looking quadratic that we're able to solve. Okay, so now if we look at it and we're like, okay, let's try the AC method. That's what we tend to look at when we have a leading coefficient bigger than 1. Well, 2 times negative 4 is negative 8. And factors of negative 8 that add up to 1 don't exist. So we know right now that's not going to be possible. Now we could complete the square, but because we don't have a leading coefficient of 1, and my b term would not be even, I don't want to do that either. So I'm just going to go ahead and dive straight into using the quadratic formula. So let's slide over here and say x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, which if I just do some simplification, I get negative 1 plus or minus the square root of, that'd be 1. Negatives are going to change to adding. We're going to end up with 8 times 2 is, 16 times 2 is 32 plus 1 is 33. So we're going to end up with 33 over 4. Okay, and that can't be simplified any further, so our answer is here, negative 1 plus or minus radical 33 over 4. And now I'd like you guys to use the same strategy. Find the least common denominator up here. Notice we have x plus 1, x squared minus 1. That should catch your eye real quick. Find the least common denominator. And then follow the same steps and solve this one. Just a quick note, ladies and gentlemen, this one happens to be equal to 1 on the right side, so you'll need to subtract that 1 over first. Okay, and you can rewrite the number 1 using common denominators. Okay, now let's slide down here and let's take a look at solving an example that has a radical in it. Okay, so the first thing we want to do is isolate the radical on one side. So I'm just going to subtract my 2 over. Square root of 4x plus 1 is equal to x minus 5. Now, to get rid of that radical, so I can get underneath and solve for my x, I've got to square to get rid of that radical. That means I got to square both sides. So 4x plus 1, that's easy. That's going to be on the left. But then you got to square this polynomial on the right, this binomial on the right. It's going to leave me with x squared minus 10x plus 25. You FOIL all of that out. Now I'm just going to make everything equal to 0, so I'm going to slide everything from the left over to the right. And I'm going to end up with x squared minus 14x plus 24. And factors of 24 that add up to be negative 14. Super simple. X minus 12, x minus 2, 0 product property. We're going to end up with x equals 12 and x equals 2. But here's the important thing you have to do. Because our radical here has a restricted domain, if the domain is ever restricted and not all reals, and we know a radical square root does not have a domain of all real numbers, you need to check your answers. So let's go ahead and check 12 and see if it works. 4 times 12 is 48, plus 1 is 49, square root that, 7 plus 2 is 9. And on the right side, 12 minus 3 is 9. 12 is an answer. Now let's check 2. 4 times 2 is 8, plus 1 is 9, square root that is 3, plus 2 is 5. Check the right side. Does 2 minus 3 equal 5? Nope. So 2 is actually not an answer. Even though you solved for it correctly, it's not an answer because it doesn't fit into the domain of our original equation. Okay, let's jump in here and let's talk about equations with rational exponents. Now, just like we did before, I'm going to go ahead and do this one. It's a little bit more difficult, and then in a second I'm going to ask you guys to do this one. Okay, but recall that if you are taking the root and that is an even root, you must consider the plus or minus cases. So whenever you take an even root, you have to take plus or minus cases. So that you'll see that here in a second. So let's go ahead and solve this one. We want to isolate our x by itself. So I'm going to go ahead and add 48, divide by 3. So we're going to end up with x plus 4 to the 4/5 is equal to 16. I'm just adding 48 divided by 3. Now, to get rid of that 4/5 power, we want to take it to the reciprocal power. So we are going to take everything over here to the 5/4 power, which means we got to take 16 to the 5/4 power. Now, what that's going to do is that's going to allow us to cancel out our exponents here and leave us with just x plus 4. That's good. Well, 16 is really just 2 to the 4th. We're going to be taking the 4th root of it to the 5th power. Now, don't forget, we took the 4th root here, so we have to have our plus or minus. Kind of running out of space there, but I'll write it right there. Plus or minus. So we end up with x plus 4 equals plus or minus the 4th root of 2 to the 20th power. 4 times 5 is 20. And how many groups of 4 are in 2 to the 20th power? 5 of them. So x plus 4 equals plus or minus 2 to the 5th, which you guys know is 32. So x equals negative 4 plus or minus 32, which negative 4 plus 32 is is positive 28, or negative 36. So there's your answers. Remember, if you take the even root, to use your plus or minus cases. If you look over here in the question you're about to do, you're going to do it to the 2/3, so it'll be odd root. You will not need your plus or minus cases. So pause your video, give this one a shot. Okay, let's jump into solving some equations that look like quadratics, but also have a little disguise to them. So if we look right here, I'm going to do the second example again, and I'm going to ask you guys to come back here in a moment and pause your video and do this example. But I'm going to do the one that's a little bit more difficult. You look and you see this exponent is twice as big as this exponent. 2/3 is twice as big as 1/3. So we know it's going to be quadratic-esque, and we can make it into a quadratic that we solve similar to a quadratic. Okay, now it still looks ugly, and if I asked you to factor this, you may not know how to do it intuitively, but that's okay. What we can do right now is we can use u substitution and say, let's let u equal x to the 1/3. If u equals x to the 1/3, then x to the 2/3 just becomes u squared. U is x to the 1/3. This is minus 7u plus 12 equals 0. And now all of a sudden you're thinking, okay, this is pretty cool. I can factor this. Okay, so u minus 4, u minus 3, 0 product property, u equals 4, u equals 3, back substitute, so x to the 1/3 equals 4, x to the 1/3 equals 3. Now recall from earlier that to solve for x to the 1/3 is equal to a number, to get rid of the 1/3, we've got to cube it. So we cubed 4, we get x equals 64, and if we cube 3, we get x is equal to 27. There's your final two answers there. Okay, now go ahead and maybe you need u substitution, maybe you don't, but take a look and see if you can solve this one. Just be wary of difference of squares factors into binomial conjugates. Okay, pause your video, give it a shot. Okay, let's take a look at some word problems here. So here we go. You're in a band with some of your friends and you're getting ready to produce a CD. Okay, you survey some friends and find out for every dollar over $10 you set the price of your CD, you're going to lose about 5 purchases from the 200 that you think you can sell. So you do believe you can sell 200, but every dollar over 10, so you think you can sell 200 at $10, but every dollar over 10, you're going to lose 5 people. Okay, so if you raise this to $11, then you would expect to only sell 195, and so on and so forth. So if the CD is paid by the parents, so this actual CD is paid for by the parents and the band members, what price should you set your CD at to make $3,000? Okay, so in this little small note, since the cost is 0, okay, the cost of the supplies is 0, revenue and profit are the same. Okay, so do you think you can make $3,000? So let's say here we want to make $3,000. We want to make $3,000. So let's figure out what we got to sell our CDs for, and so on and so forth. So we know that revenue, and I'll make a little note, revenue is equal to price times sales. Okay? Sell one CD for $10. Okay, $10 times 1, you make $10. $10 times 2 sales, you make $20, and so on and so forth. So price times sales. So the price of our CD is going to be $10 plus whatever we raise it, X amount of dollars. Okay, because if we only sell it for $10 and we sell 200 of them, it should make sense. Like, hey, you're only going to make $2,000. We're trying to make $3,000. Okay, now the number of sales that we're going to sell, the number of CDs we're going to sell, is equal to 200. That's what we think we can sell it for. That's how many we think we can sell if we sell it for $10. Remember, $10 gives us 200 sales. Minus 5 people for every $1 we go above $10. So you see real quick here, we've got ourselves a nice quadratic. If I FOIL all that out, I get negative 5x squared plus 150x plus 2,000. And to solve a quadratic, you want to make it equal to 0. So I'm going to move everything to the left. So we end up with 5x squared minus 150x plus 1,000 equals 0. Now that looks kind of tough to solve. You can do quadratic formula. You can do whatever you want, the big numbers. But I notice everything's divisible by 5, so I'm just going to divide everything by 5. So that's going to give me x squared minus 30x plus 200 is equal to 0. So a little bit easier to solve now, a little bit easier to factor. Factors of 200 that add up to negative 30, that's negative 10 and negative 20. And applying the zero product property, you get x equals 10 or x equals 20. So recall that x equals 10, x equals 20, that's how much you're going to raise the price over $10. So what that means is that means a $20 CD. And this one means that you're going to have a $30 CD. Okay, so if you sell the CD for $20, you'll make $3,000. Or if you sell the CD for $30, you're still going to make $3,000. Both of those are probably too expensive for a CD, considering you can go on the internet and download music for much cheaper or even free. Okay, so you're probably not going to end up making your $3,000. Okay, let's take a look at a work application here. So everybody seems to love these problems. If worker A takes 2 hours to paint a room, and worker B takes 3 hours to paint a room, how long will it take them both together to paint that same room? Okay, so the first thing we've got to understand is that for worker A, they are going to paint half the room per hour. And worker B is going to paint 1/3 of the room per hour. Okay, it should make sense because if worker A takes 2 hours to paint the room, he's going to do half the room in an hour. And worker B, if they take 3 hours, you're going to do 1/3 of the room per hour. Okay, per hour. All right, so we're trying to solve for how many hours would it take them to paint the room. Okay, so if they're moving at a rate of half a room per hour and 1/3 of a room per hour, and a room is represented by one whole room, we can say that 1/2 h plus 1/3 h needs to equal 1. One whole room. Half the room per hour plus 1/3 of the room per hour is equal to a whole room. Okay, so we're trying to solve for however many hours. Now we got these fractions here, so of course we want to get rid of our fractions. We don't like dealing with fractions, so let's just go ahead and multiply everything by 6. Okay, least common denominator there, 6. So 6 times 1/2 is 3, so we got 3h. 6 times 1/3 is 2. And 1 times 6 is 6. So 5h equals 6. H equals 6/5, which is 1.2 hours. Okay, last one. Let's dive into this. And it's very, very similar, but it's a little bit different. So worker A takes 3 hours more than worker B. We don't know how many hours. We just know 3 hours more than worker B. Okay, to cut the grass, paint a room, doesn't really matter. 4 Mile Highway, that number's there just to mess with your head. Okay, so if they can cut the median together in 2 hours, oh look, they're giving us the h. So up here in our previous, we didn't know h, but now we know it's 2. They want to know how long would worker A take to solve, or take to mow the grass, paint the room, whatever you want to call it. The questions are about the same. So if we got worker A and worker B, and we know worker B paints or mows the grass in X amount of hours, and worker A takes 3 more hours. Okay, that means that worker B is going to mow 1/x of the grass per hour, and worker A is going to mow 1/x plus 3 of the grass per hour. So we're going to set this up the exact same way we did before. Okay, 1/x plus 3 plus 1/x needs to be equal to a whole median of the grass being mowed, or a room painted, or whatever. Now we told you they're giving us the hours. They give us the h like we used before. Okay, so we could say, and we know the h is going to be 2 hours. So let's go ahead and solve. So we've got 2/x plus 3 plus 2/x has to equal 1. Now in order to combine these two fractions, we got to have common denominators. So we're going to multiply. I'm going to go over here and do it. We need to multiply this fraction on the top and bottom by x. and this one by x plus 3 on the top and bottom. So let's go ahead and do that. So on top, we're going to have 2x, and that's for this one right here. And over here, we're going to have 2x plus 6 all over x times x plus 3 is equal to 1. And run down space, but that's okay. Now, to solve this, it's not equal to 0. I wish it was because it'd be easier, but it's not. So we're going to multiply this denominator over to the right side. Okay, so the numerator is 4x plus 6, and multiplying this over to the right side, you end up with x squared plus 3x. Oh, it's starting to look like a quadratic. That's pretty good. Let's make it equal to 0. So let's subtract our 4x and our 6 over. So you end up with x squared. Subtract your 4x, that's minus x, subtract your 6. Now it's easily factorable. X minus 3x plus 2. So x is equal to 3, or x is equal to negative 2. Okay, now it should make a little bit of sense why one of them doesn't make sense. Okay, it's impossible for, think about worker B who cuts the grass in X amount of hours. They can't cut the grass in negative 2 amount of hours. So that's not the case. Okay, so then does 3 work? Yes, 3 works. Worker B can cut the grass in 3 hours, which means that worker A cuts the grass in 6 hours. Thank you very much. Make sure you bring your questions to class. Look forward to talking to you about them.